this lesson, we're going to talk about valence electrons and how we can determine how many valence electrons different atoms have. So a valence electron is the electron in the last shell or energy level of an atom. It can participate in the formation of chemical bonds with other atoms or ions. So to determine how many valence electrons an atom has, there are two methods. The first is to draw an electron dot diagram, and the second is to use the periodic table shortcut. First, we're going to go through the method of drawing the electron dot diagram using silicone. So silicone has 14 for its atomic number, so we know it has 14 electrons. So first we start by putting an SI in the middle. Our first orbital, we know, has 2 electrons in it. So we put 2 dots around it. The second one can hold 8 electrons, so that gives us 3, 4, 5, 6, 7, 8, 9, 10. We've used up 10 of our electrons. Now we have our next energy level. It can hold another 8. So we're starting at 10, going to 11, 12, 13, and 14. So we filled up these energy levels with silicon's 14 electrons. So we can see the outer energy level has 4 electrons. So silicone has 4 valence electrons. So this is a really good way of actually looking at it and seeing a picture to determine how many valence electrons there are. There's a really quick way to do this too, and that's method 2, using the periodic table. So, using the periodic table, the number of valence electrons correspond to what group number that the atom falls under. And this is true for most of the atoms or elements on the periodic table, but not quite all of them. So we'll go through them. So group 1 does have 1 valence electron. Group 2 has 2 valence. I'm going to do this to represent electron. Group 3 through 12 have irregular numbers. This is because they're the transition metals, so they can have different numbers depending on their configurations. Group 13, we pick back up with 3 valence electrons. Group 14 has 4 valence electrons. Group 15 has 5 valence electrons. 16 has 6 valence electrons. 17 has 7 valence. And 18 has 8 valence. And since 8 valence electrons usually signifies being a full orbital, you could also kind of look at that as being 0 valence electrons, because we know group 18 is our noble group, our noble gases, so they really don't react with anything. So silicone is in group 14. So that's right here. And it says, as you can see, we have 4 valence electrons. So that works out as well. So we did 2 different methods, got the same answer. So now we're going to do an example problem. And that's going to be, what would the charge be for a sodium silicate polyatomic ion? So first we need to determine what the charge would be on both of these 2 ions separately. So sodium, Na, is in group 1. So we know it has one valence electron. So whenever you have less than 4 valence electrons to become an ion, you usually donate or lose the electrons. So therefore, sodium is going to become Na+ because it gave away its one valence. Okay, now we're going to look at silicate, which just means silicon. And like we said a second ago, silicon has 4 valence electrons. And whenever you have 4, you go the opposite charge as your other interacting atoms. So therefore, silicon goes to Si 4-. It gained 4 electrons. So now we just need to add these two ions together. So we have sodium plus silicon 4-. And when we add those, we're going to get sodium silicate. And those charges just add. So you have plus and 4-, so you're just going to get 3-. So that's going to be your polyatomic ion there is a sodium silicate, which is a 3-.